class, this section we're looking at is 9.4. It covers symmetry, increasing and decreasing functions, and even and odd functions. The first thing I want to go over is 3 different types of symmetry. So our first type of symmetry is symmetry with respect to the x-axis. Okay, here's our x-axis, and if I was going to fold the graph of this parabola that's been rotated 90 degrees along the x-axis, the graph would meet up. Okay, so if I replaced y with negative y, I get the same equation. I would still get a. It's important to note that this graph right here, although it does look like a parabola, is no longer a function because it fails the vertical line test, right? I've got 2 points of intersection as I go along this graph. The next type of symmetry is symmetry with respect to the y-axis. So here we have a graph of a parabola, right? It's our most basic parabola, y equals x squared, okay? This is still a function. It passes the vertical line test. And we call this symmetrical with respect to the y-axis because if I folded the graph up along the y-axis, it would meet up, okay? So if I exchange my x with negative x, I'm going to get the same value. This is an example of an even function. Last and certainly not least, I'm going to take a look at this function. This function has symmetry about the origin, right? What's that mean? Well, if I rotated this 180 degrees, it would still be symmetrical. We call these odd functions, okay? So even functions have symmetry with respect to the y-axis, and odd functions have symmetry with respect to the origin. Okay, to graph, to determine if an equation is symmetric with respect to the origin, okay, what we need to do is substitute x with negative x and y with negative y in order to see if it results in an equivalent equation. Okay, that's going to be true for all graphs with symmetry to the origin. Symmetry with respect to the origin. So I'm going to plug in negative x for x, and I'm going to plug in negative y for y, and I'm going to go ahead and simplify this, right? So let's go ahead. Negative x squared, that's going to be negative x times negative x. That gives me a positive x squared, plus I've got negative y squared. That's just going to give me a y squared. So because our original function, when we substitute negative x and negative y, gives us an equivalent equation, we know that this circle, whose center is the origin, is symmetrical with respect to the origin. So let's try again and see if this also gives us symmetry with respect to the origin. So if I have negative y, because I'm substituting y for negative y, and then I have negative x cubed, okay, that gives me negative y equals negative x cubed is still going to be negative x cubed, okay. Well, let's go ahead and divide both sides by negative 1, right? We want that coefficient on our y to be a 1. That gives me y equals x cubed. So this cubic equation is an example of an equation with symmetry with respect to the origin. So a function is an even function if it has symmetry with respect to the y-axis, and a function is an odd function if it has symmetry with respect to the origin, okay? Functions don't have to be even or odd, just so you know they can be neither. So in order to tell if a function is an even function, if I substitute in negative x and I get back f of x, our original function, it's going to be symmetric with respect to the y-axis. If I plug in negative x and it's an odd function, my result will be negative f of x, okay? So we're just going to substitute for negative x in order to solve these. So I have f of negative x equals 8 negative x to the 4th minus 3 times negative x squared plus 1. So that gives me f of negative x equals 8. Negative x times itself 4 times is going to give us just x to the 4th, positive x to the 4th, minus 3. Negative x squared is going to give us x squared plus 1. So f of negative x is equivalent to f of x. That means that this is an even function. There we go. Let's try this again. So I'm going to substitute a negative x for x in order to determine if this function is even or odd or neither, right? That's our third option. So if I take f of negative x, that gives me 6 times negative x cubed minus 9 times negative x. I would get negative x cubed is going to be a negative x cubed times 6. That gives me negative 6x cubed. Negative 9 times x gives me a positive x. Our new function looks kind of like our original function, except the signs are changed. Let's go ahead and take a look at what negative f of x would be. If I had negative f of x, that would give me a negative, because we distribute that negative, negative 6x cubed, and then a negative times negative 9, that'd give me a positive 9x. All right, so we can see that f of negative x equals negative f of x. So this is an example of an odd function. All right, one more time. Let's see if it's even, odd, or neither. So I'm going to substitute in negative x for x and see if I get f of x or negative f of x as my result. If I get neither of those, our result would be neither. Hint, hint, wink, wink. So let's try this out. I have f of negative x, put some parentheses in there, equals 3 times negative x squared plus 5 times negative x. That gives me 3 negative x squared gives me a positive x squared. But 5 times negative x gives me a negative 5x. Okay, so f of negative x doesn't look like f of x, right? There's a minus in the middle. And it also doesn't look like negative f of x. Negative f of x would have given me negative 3x squared minus 5x. And I don't have that, right? So since f of negative x doesn't equal f of x, it's not even. And since f of negative x doesn't equal this negative f of x right here, my function is an odd, so it is neither.